Okay, there are two ways to balance redox reactions. One of them uses oxidation numbers. When we are balancing these redox reactions, we need to balance for atoms, which is all you know about balancing to this point. We also need to balance for the number of electrons passed. Yes. One thing is going to be oxidized, something else is going to be reduced, and the number of electrons that one is giving up and the other one is receiving have to be balanced. And also charge. Sometimes things in these reactions will have a charge, and we need to make sure that we're consistent on both sides of the arrow. So here is our set of rules. First thing, write the correct formulas for all the reactant products. Boom, done. Assign oxidation numbers to the atom in the equation. If you're actually doing this along with me, why don't you pause the video and practice knocking out the oxidation numbers. That's got them. Now I'm going to look for what is changing. So Cu seems to be going from 0 on this side to 2 on that side, and N, some of the N, not all of it. Some of the N is staying the same, but N is going from 5 down to 2. So this is a change of +2. This is a change of -3. So far I'm actually happy because one is up and one is down. If I had them both in the same direction, I would have assigned oxidation numbers incorrectly. So if one is changing by 2, another one is changing by -3, a good number to shoot for would be 6. Whoa, shoot for change of 6. So in that case, I want the ratio of Cu to N to be, I need 3 Cus for every 2N, and then I would have -6 for both, or +6 and -6. Number of electrons transferred would be the same on both sides. Did number 3. State the number of atoms. Yes. Oh, I'm gonna do that now. I'm gonna put in, I need 3 Cus. I like to leave big gaps here to change numbers. I need 3 Cu. I need 2N. I need 2 N's. Yes, 2NO plus H2O. Make the total increase. I did it. Use this. Balance the remainder by inspection is where I am now. So I have, how many N's over here? I have 2, 6, 7, 8. It looks like I'll need an 8 here. 8 H's. Looks like I'm going to need a 4 here. And then I think everything is balanced. So I'm just going to check the O's. 24 O's. That's a 3. I'm going to make that a bit more clear. That's 6, 18, 19, 20, 24. Boom. This guy is balanced for atoms, electrons, and charge. Now I know some of you are thinking I could have done that without all this oxidation number garbage, but the next one, not so much. this guy. Now this guy is in an acidic solution, so first thing I'm going to do is I'm going to assign oxidation numbers. I'm going to get a -2, I'm going to get a +1, 4, looks like P is a 1, -2, 14, looks like that CR is a 6, +1, -2, -8, looks like P is a 5 here, and CR is going to be a +3. So it looks like P is going from 1 to 5, 1 to 5, and CR is going from 6 to 3. One is up, one is down. So I've got one changing by 4, the other changing by 3. If I want to make the amount the same in both, looks like I should shoot for 12. Yes? So I want the ratio of P to CR to be equal to 3 to 4. Now, I will write 3 H3PO2 plus, now I want 4 CRs, there's already a 2 here, so I'm going to put a 2 CR2O7 minus 2. I'm going to get an a 3 H3PO4 plus 4 CR plus 3. Yes? Next up, should balance for charge. This side of the equation has a charge of -4. This has no charge. I have two things at -2, gives me -4. This side has a charge of +12. I'm going to add in H pluses to balance for charge. How many H pluses do I need to balance for charge, and where will they go? I need 16 H pluses over here. So I'm going to write 16 H plus 3 of those guys. And now notice the charge over here is +12 and the charge over here is +12. Now I'm going to help myself out by looking at the H's. I've got 9 here, 9 here. Looks like I'm going to need, I'm going to balance for H's by adding in water. And it looks like I'm going to need, since there's 16 extra on this side, looks like I'm going to need 8 on that side. So 16 H plus. I need 3 of those. I need now I cross my fingers and I hope that the number of O's works out here. Here I've got 6 and another 14 makes 20. Here I've got 12 and another 8 makes 20. The O's balance, the CR's balance, the H's balance, the P's balance. This thing is balanced for atoms, it's balanced for charge, and it's balanced for electrons passed, because the ratio here is 3 to 4. One last one. That was an acidic one. Let's try a basic one. So the rules for basic are exactly the same. There's just a little, 2 little steps on the end. So I'm actually going to start off by thinking that this thing is an acidic solution. So I am still going to assign oxidation numbers. Switch colors. -2, 7, -2, 3, minus 2, 4, minus 2, 4. Yes. Oh, what did I do wrong? I made a mistake here. This should be just C2O4 minus 2. Sorry, I made a mistake. I got carried away looking at the wrong example. C2O4. So minus 2. Still going to be 3 here. So looks like Mn is going from 7 to 4, and C is going from 3 to 4. This is a change of minus 3. This is a change of plus 1. Yes, I'm going to shoot for a change of 3. Yes, so the ratio of Mn to C, I need 1 Mn for every 3 C, and I would be in business. Now I've got a 2 here, which is going to cause me a problem in a minute. So what I'm going to put here is I'm going to double everything. So I'm going to get 2 MnO4 minus. I'm going to need a 3 C2O4 minus 2. I'm going to need a 2 MnO2. And I'm going to need a 6 CO2. Now the ratio of C to Mn is still 1 to 3, except I've used 2 to 6 because of this guy right here is messing me up. Charge. Charge on this side is minus 2, minus 8. Charge on this side is 0. Yes. So I need to add in some OH minus to balance it, and I'm going to balance it by putting 8 OH minus over on this side. 2 MnO4 minus. I need 3 of these C2O4 minus 2s. I need 8 OH minus. I need a 2 MnO2. I need a 6 CO2. Now when I look at the H's, no H's, no H's, H's, H, looks like I've got 8 H's here, so it looks like I'm going to need 4 waters over on this side to finish it, and hopefully that would also work for the O's. I see 4 and another 8 makes 12, and another 12 makes 24 O's on this side. I see 8, I see 12, I need another 12, makes 24. This thing is again balanced for charge, electrons, and atoms. So there's 3 examples, one in an acid, one in a base, and one in a neutral solution.